Good morning friends. Today we are going to solve some more sums related to the section formula. I am having a question here. Find the coordinates of point A where AB is the diameter of a circle. This is given that AB is the diameter of a circle whose center is 2, -3 and B that is 1, 4. So from this question we can find out that the given situation represents a circle having a diameter AB where center, let me name the center as C, and this is our diameter passing through the center of the circle, right? So this represents us a circle with diameter AB and center C. Now we are given that the center of the circle is 2, -3. So this will be 2, -3. The coordinates of B are given, that is 1, 4. And we need to find out the coordinates of A. Yes or no? Now as per the given condition, we can say that here let the center of the circle be C 2, -3 and given that B is 1, 4. Let the coordinates of A be x, y. As AB is the diameter and C is the center of the circle, as AB is the diameter and C is the center of the circle, C is also the midpoint of diameter AB. Yes or no? C is also the midpoint of diameter AB because center to any point on the circle is equals to radius. So here we can say that CB is equals to radius and CA is also equals to radius, as AB is the diameter. So C is the midpoint of AB. Therefore, using the special case of the section formula, C is equals to x1 plus x2 by 2. So we shall take x1 y1 as 1, 4 and x2 y2 as x, y. Therefore that will be x plus 1 by 2 y plus 4 by 2. Yes or no? So this is how the section formula, the special case of the section formula, is applied by the midpoint theorem, or also known as the special case. Therefore we are having the coordinates of C, that is 2, -3 is equals to x plus 1 by 2 y plus 4 by 2. Comparing the coordinates of x and y on both sides, we get 2 is equals to x plus 1 by 2 -3 is equals to y plus 4 by 2. Therefore 4 is equals to x plus 1. This 2 will be multiplied on the other side. Here also this 2 will be multiplied. That means -6 is equals to y plus 4. Taking 1 on the other side, that is x equals to 4 minus 1. And here y equals to -6 minus 4. So you will take 4 on the other side, that will become minus. Here this plus 1 will become minus 1. Hence x is equals to 3 and y is equals to minus 10. Therefore the coordinates of point A are 3 comma minus 10. Is it clear? Therefore the coordinates of point A are 3 comma minus 10. So we got the other end point of the diameter, that is again 3 comma minus 10. Is this thing clear, friends? So that is how you can find out. Don't hesitate what to do, just understand the question, try to draw a figure if possible, and then simply solve according to the method that is known to us. Okay, so take a look over it and then I'm going to erase. Okay. Now I'm having one more question. That if A and B are minus 2 and 2 comma minus 4 respectively, find the coordinates, find the coordinates of P such that AP is equals to 3 upon 7 AB and P lies on the line segment AB. We are given a condition here, friends. We are given a question here that the coordinates of A and B are given. This is the coordinate of A and that is the coordinate of B. And this is given that AP equals to 3 upon 7 AB. Right? That means you can say that AP is 3/7 part of AB. Yes or no? We can say that AP is 3/7 part of AB. That means AB will be greater than AP. You can simply say that AB will be 7 parts and AP is third part of the total AB. Therefore, here given that A minus 2 and B 2 comma minus 4 and also AP is equals to 3 upon 7 AB. Yes or no? This is given, right? 3 upon 7 AB. So from this, if I draw a figure that P lies on the line segment AB, that means it will be somewhat like this. This is my A, this is my B, and this is somewhere P here, right? So what can you write down from the figure? That AP plus PB is equals to AB. Yes or no? So can I replace AB equals to AP plus PB here? Therefore AP is equals to 3 upon 7 into AP plus PB. Is this thing clear or not, friends? What I have done, I am going to find out the ratio. I am going to find out the ratio of AP is to PB, because we require M1 is to M2 in the section formula. But we are not given M1 is to M2. What we are given is M1 is to total M1 plus M2. That is what we are given. So for finding out M1 is to M2, what we are going to do? We are going to replace this total AB here in the given condition. Yes or no? So in place of AB, if I replace AP plus PB, is it good? Therefore this 7 will be multiplied here, that is 7AP is equals to 3AP plus 3PB. Therefore 7AP minus 3AP is equals to 3PB. This 3AP I have taken on the other side, so that has become minus. Therefore 4AP is equals to 3PB, and hence AP upon PB is equals to 3 upon 4. So friends, you can clearly see that now we have got AP upon PB, that means AP is to PB, or you can also write it as AP is to PB is equals to 3 is to 4. Yes or no? AP is to PB is equals to 3 is to 4. Now we need to find out the coordinates of P. So let me erase this now here. Is it good? So we got the ratio here, that is our M1 is to M2. So now therefore here, or the ratio in which the point P divides the line segment AB is 3 is to 4, that is equals to M1 is to M2, and let A minus 2 is equals to x1 y1, and B 2 comma minus 4 is equals to x2 y2, right? So we have taken this 2 as x1 y1, A minus 2 as x1 y1, and B 2 minus 4 as x2 y2. Therefore applying the section formula, we get the coordinates of P, that is m1 x2 plus m2 x1 upon m1 plus m2 comma m1 y2 plus m2 y1 upon m1 plus m2. Okay, this is the formula. Let us put down the values here. That is equals to 3 into 2 plus 4 into minus 2 upon 3 plus 4 comma 3 into minus 4 plus 4 into minus 2 upon 3 plus 4. Right, simplifying this we get that is equals to 3 into 2 6, 4 into minus 2 minus 8 upon 7 comma minus 12 minus 8 upon 7, which gives me minus 2 upon 7 comma minus 20 upon 7, and these are the coordinates of point P. The required coordinates of point P are minus 2 by 7 comma minus 20 by 7. So the coordinates of point P which divides the line segment AB in the ratio 3:4 are minus 2 by 7 comma minus 20 by 7. Is it clear, friends? So what was given here, just take a look that AP is 3/7 part of AB, right? We were not given direct ratio, we were given indirect ratio. So first of all, what we did, we found out a ratio from this, and after finding out the ratio, what we did, we used the section formula to clearly find out the coordinates of point P, that is the point of intersection, right, or the point of division. Okay, take a look. Now I'm having a question, that is, find the coordinates of the points which divide the line segment joining A minus 2 2 and B 2,8 into 4 equal parts. Okay, so friends, here you can see that we are having a line segment AB with the coordinates of A and B given to us, and we need to divide this line segment into 4 equal parts, and also we need to find out the coordinates of those points of division. So let me first draw a line segment here, that is AB, A and B. Now we need to divide this into how many parts? 4 parts. So how many points we will have? 1 less than number of parts, so that will be 3 points. 1, 2 and 3. Let me extend this somewhat here so you can clearly see. So let the points of division be P, Q and R, with this given A as minus 2, 2 and B given as 2, 8. Okay, so now we need to find out these points of division P, Q and R, as they are 4 equal parts. Let us say that all the parts are having a distance of 1, 1. So this will be 1, this will also be 1, and the last one will also be 1. So what can you say about P? This is 1 and this distance is 3. What can you say about Q? This distance is 2 and this distance is also 2. And what can you say about R? This will be 3 and this will be 1, right? So friends, here you can clearly see that as the points are lying between A and B, those points are dividing the line segment AB in some ratio. If we take the ideal condition, that is 1 1, that means let us say that ideally the distance between all of this or all of these parts are of 1 centimeter each. Then what to do? Then this P will be at a distance of 1 unit from A, and it will be at a distance of total 1, 2 and 3 units from B. So the ratio of division of this line segment AB for point P is 1:3. Similarly for Q it will be 2:2, and similarly for R it will be 3:1, right? So let us continue with the solution here. That here given A -2, and B 2, 8, and let the points of division be P, Q and R, where P divides line segment AB in the ratio 1:3 from A. Q divides line segment AB in the ratio 2:2 from A, and R divides line segment AB in the ratio 3:1 from A, right? So we have got these three conditions, that P divides line segment AB in the ratio 1:3, Q divides in the ratio 2:2, and R divides in the ratio 3:1 from A. So first of all, what we shall do, we shall find out the coordinates of points, right? Let us start with the coordinates of point P. So we can say that the coordinate of point P, therefore applying the section formula, P is equals to, here M1 is to M2, or M1 and M2 are 1 and 3. Let this A -2, 2 be taken as x1, y1, and let this 2, 8 be taken as x2, y2, right? I forgot to write it there. So this -2, 2 is equals to x1, y1, and 2, 8 is equals to x2, y2. Okay, putting down in the formula, that is m1 into x2 plus m2 into x1 upon m1 plus m2 comma m1 into y2 plus m2 into y1 upon m1 plus m2, right? So we are having this formula here with the values put. Let us simplify. That is equals to 2 into 1 2, 3 into -2 -6 upon 3, 4, my mistake, comma 8 plus 3 into 2 6 upon 4, Okay, so simplifying this, we will get minus 4 upon 4 comma 14 upon 4. Therefore, coordinates of P are minus 1 comma 7 by 2. So this is the first coordinate that we got for the 4 parts that we require. So that is equals to, sorry friends, pardon me for a second, that is your x1 y1. So we got P as minus 1 comma 7 by 2. Okay, that is how we get the coordinates of P. Now finding out the coordinates of Q. Now as Q divides line segment AB in the ratio 2:2, so Q is also the midpoint of line segment AB. Therefore, Q equals to x1 plus x2 by 2, that is minus 2 plus 2 by 2 comma 2 plus 8 by 2. Right, we can directly apply the midpoint theorem, the special case of the section formula. So minus 2 plus 2, that is 0 by 2 comma 10 by 2. Therefore, the coordinates of Q are 0 comma 5. So we got the second point, that is Q 0 comma 5. The first one we got P as minus 1 comma 7 by 2. We got Q as 0 comma 5. Now we shall get R. Right, now we find the value of R. Now R is equals to, again you take this 3:1 here as m1 is to m2. So m1 equals to 3 and m2 equals to 1 for finding out the coordinates of R. Or you can simply reverse the values of m1 and m2 here in coordinates of P. So that is 3 into 2 plus 1 into minus 2 upon 3 plus 1 comma 3 into 8 plus 1 into 2 upon 3 plus 1. Is it clear? What did we do? We simply reversed m1 and m2 in the coordinates of P, or if you apply again the section formula for finding out the coordinates of R, where m1 is to m2 equals to 3:1 and x1 y1 and x2 y2 are the coordinates of A and B, then also you will get the same result. Simplifying this, what do we get? That is 3 into 2 6 minus 2 upon 4 comma 3 into 8 24 plus 2 upon 4. So that gives me 6 minus 2 4 upon 4 comma 26 upon 4. Therefore, coordinates of R are 1 comma 13 by 2. So we got the third coordinates here, that is coordinates of Q are 1 comma 13 by 2. So that is 1 comma 13 by 2. Right. hence we got all the coordinates of the points which divides the line segment AB into 4 equal parts. The first one is -1, 7 by 2, the second one is 0, 5, and the third one is 1, 13 by 2. Is this thing clear? Friends, this question is exactly same as that of the trisection question that we have solved previously, right? In the trisection we had only 2 points of division, whereas in this question we have 3 points of division. So the method is exactly same as that of the previous one. There is no change in the method, only there it was trisection and now we are having 4 equal parts. Is this thing clear? So that's it about the questions regarding the section formula, right? That is all about the questions regarding the section formula. Now in the next lecture, friends, we shall start with the next topic, that is the area of the triangle. Is it clear? So that's it for today's lecture.